Welcome to another session of microwave engineering. Today we are going to deal with microwave components. So some of the components which you are going to learn in today's lectures are T junctions and action couplers. To exactly know what exactly is this T junction? T junction means three independent ports. Now depending upon how you are going to place your auxiliary arm. When I say auxiliary arm means the side arm. And this is your main arm or your collinear arm. Suppose you have three independent ports, port 1, port 2 and port 3. Now in this the side arm, your side arm is placed in a direction parallel to electric field. How do I say that? Because electric field is always shown in a vertical polarization or horizontal polarization. So you can see since your side arm is in a direction parallel to electric field, this T junction is called as E-plane T. Because of this projection, this is called as E-plane T. How do I explain the properties of this? It has been observed that whenever two signals enters to port 1 and port 2, whenever two signals enters from port 1 and 2, can you see the diagram over here? Whenever two signals enters to port 1 and port 2 are of equal magnitude, they are both equal magnitude but opposite in phase. Can you see over here? This is upwards. Yes, and this is downwards. When both are equal in magnitude and opposite in phase, when they both enter through port 1 and port 2, what happens in port 3? Both gets added up. Can you see over here? Both gets added up. Both gets added up. So you get sum of voltages. So two signals of equal magnitude when an opposite phase enters from P1 and P2, power in port 2 or signal in port 2 will be doubled. What happens when two signals of same phase, you can say, or the opposite of this property is when power enters or when signal enters to port 3, that signal will be divided into two signals of equal magnitude but opposite in phase. Am I clear? Now how do we write this in Smith chart using scattering matrix? That means if you say two are equal in magnitude, then opposite in phase, this is S, this is 1, this is 3, this is 2, this is 3. So how do I write this equations? I will just write this equation as, can I say this? S1, 3 will be always equal to minus of S2, 3. What does it mean? What does it mean? Whenever power enters through port 3 to 2, it will be opposite in phase to power found when it is input from port 3 found at port 1. So S13 will be always equal to minus of S23. So the three-port matrix, that is the S matrix of a three-port network, will be always given as S11, S12, S13, S21, S22, S23, S31, S32 and S33. Why did we take S11, S22 and S33 as 0? The reason for this is very simple. It is because we are assuming that all the ports are matched, meaning there will not be any reflection from the port which is, if suppose power is incident at port 1, there will be no reflection from port 1 itself. Assuming this, S11, S22, S33, meaning all the diagonal elements I'm saying, will be assumed to be 0. All diagonal elements is going to be 0. What difference can you make in this equation? One more difference I can do over here is that you just now said S13 is equal to minus of S23. That means wherever S23 is there, which is your S23? Wherever S23 is there, what can I substitute? Minus of S13. Minus of S13. What does S31 mean? S31, can we say this is a reciprocal network? What do you mean by reciprocal network? S13 equal to S31, S12 equal to S21. So if you want, I can also write, instead of S31, I can write over here S minus S31. It's similar. I'm just trying to say that how you can reduce the S matrix. You can see that in the next equation which you can see. S12, S21. So you can write here S12 also. It is similar, but it doesn't affect because for our this it is not affecting anywhere, right? You can just see the final how they have written. They have written S11, S22. This is a mistake. This should be S22, S11, S22, and S33. Over here, they have not assumed it to be perfectly matched. Therefore, they have kept it. Otherwise, normally we assume to be perfectly matched. Can you see over here? They have changed it. S13 over here. They have changed it. See over here, they wrote it here minus S13. Why do you think they have written it over here? Because according to the definition of a three-port network, here it was S. What should come over here? Here it was S31. You have written S13 is equal to S31. So wherever S31 was there, right? Sorry, it is S32. So this is S32. This is actually S32. S32. What is S32 mean? Reciprocal network means it is equal to S23 and S23 became equal to minus S13 according to the definition. You recollect that diagram? Recollect the diagram of E-plane? I hope you remember it. Right? This was 1, this was 2 and S3. So I am trying to tell you this. Here, according to S matrix of three-port network, here it was S32. S32 can be written as S23 reciprocal network, but S23 is equal to minus of S13. That is substituted. Right? Here also it was what? S31 reciprocal. You wrote it as S13. Clear? Here it was what? S21 reciprocal S12. I hope you got these definitions. Yes, this is how you apply scattering matrix for a three-port network. For this, the property should be known to you, then you can directly apply. You can for that go through the slides of S matrix which is explained before, and then you can easily visualize this for each component. Let's take care of H-plane T. What is H-plane T? It's also called as a shunt plane T. What's the difference is that what is this? This is your side arm. Can you see it is in a direction? This is in a direction parallel to magnetic field. See, electric field we show it like this, but magnetic field is always shown as a coil. I hope you know that. So this time your side arm is in a direction parallel to magnetic field. So this becomes a H-plane T. H-plane T. Properties of H-plane T is exactly similar to E-plane T, which are difference that whenever two signals are entering from port 1 and port 2 of a H-plane T, power, that is the power in this will be doubled provided that both the signals will be of same phase. You remember in E-plane T we said opposite phase. Here it is going to be same. I repeat, if signal enters to port 3 of an H-plane 3, the signal will be divided into two signals of equal magnitude but same phase. What did I say? It should be always same phase. Please note this, it should be always in phase or same phase. Then only additive. Otherwise, this does not work. Now, I am asking you one simple question, that what will be the S matrix then? In a case of S matrix, it will be exactly same as E-plane T. Only difference is that minus sign will not be there. Am I right? Minus sign will not be there. Your S13 will be equal to S2 of 3, but it will be minus sign should not be there for a H-plane T. Am I clear? Yes, I hope you understood this. Now, when we talk about combination of E and H-plane T, next comes the topic called as magic T. Other name of this magic T is also called as hybrid T. What is the name? It is also called as hybrid T. It is also called as hybrid T. Now let us see magic T. How is this magical T? Magic T is nothing but combination of E-plane T. You can see over here, it's a combination of E-plane T and an H-plane T. Can you see? It's a 4:4 matrix. The diagram which I have made over here is a 4:4 matrix. Your T junction and your T junctions, E-plane T and H-plane T, both were two-dimensional. I mean 4:4 matrix. Here it is 3:3 matrix. This is going to be 4:4 matrix. It is very simple to understand magic T because it is just a combination of E and H plane. So how do I explain normally to my students is that I always ask them to draw this plus line. Okay, so this becomes 1, this becomes 2. For me, this becomes my E arm, students. This is my E arm. Okay, then it becomes easier to understand. And this becomes my H arm. Now help me in writing the properties. Very simple. When two signals of equal magnitude and opposite phase enters from P1 and P2, Power in P3 will be double because it is opposite phase. So ER, and power in HR will be 0. That means this port 4, it will be 0. Whenever two powers of or two signals of equal magnitude enters from P1 and P2, power in P1 and P2 of equal magnitude and equal phase, same phase, then power in HR will be double and no power will be there in 3. Third property, when a signal enters from port 4, signal will be divided into two signals of equal magnitude and same phase. Whenever signal enters from port 3, signal will be divided into two magnitudes, that is two signals of equal magnitude and opposite phase. I hope the properties are clear now. It is just combination of E and HR. So if you make this diagram, it becomes more easier. Now according to that, whatever properties we just discussed, the same way S matrix can be also written. We are assuming over here S11, I'm just telling you all the S matrix, S11, S12, what is this? S21 and S22. Now here all the diagonal elements are kept to be 0. Why are the diagonal elements kept to 0? I already told you they are assuming all the ports to be matched. When the ports are matched, what happens? S11, S22, S33, S44, all the diagonal elements, I'm talking about these, all the diagonal elements are going to be 0, or always going to be 0. Alright, that is first assumption done. Now, what do you think has happened to your S12 and S21? This is S21. Do you agree with this? This is S12. What is this? S21. Since S12 is 0, S21, which is reciprocal of that, also became 0. Let us see S12. What is S12? According to my diagram, tell me which is S12. Which is S12? Can I say S12 is this one? Yes. S12. Yes. Please note, can signal enter alone from 1? No. Signal cannot enter from 1. Signal has to enter from both the sides, 1 and 2. Then only something will happen in 3 and 4. Are you getting? Can signal enter from 3 and happen only in 1? 2, nothing will happen? No, not possible. So, in other words, these ports alone in isolated mode cannot work. So, we say that signal from S12, when I write S12, the meaning I hope you remember, in S matrix I have already told. When I write S12 means signal entering from port 2 reflected from 1. So nothing is going to enter from port 2 alone. Never. Signal will be always entering from 1 and 2 simultaneously. Hence we have taken S12 and 21 to be 0. To be 0. Similar lines will happen over here for your, this is going to be 31 and 13. 31 mean, not 31 and 3, I'm sorry. I said wrong, not 3-1. I mean to say similar lines explanation will take place over here. What is this one? What is this? 3-4. Can signal alone take place over here like this? Can it happen like that? 3-4. Can signal enter or go out from only these two ports? Not possible. So 3-4 and 4-3 also we are going to take it as 0. That is why you have this matrix in this form. If you want, you can go into depth also, students, like S13 will be equal to 2 S23. S13 can be minus of S23 depending on which arm you are taking. For example, if you take E arm, can I say S13 is equal to minus of S23? Yes, because it's opposite phase. Similarly, S14 can be equal to S24 and it's going to be equal to positive value only because they are going to be in phase. But substitute, you'll get the final S matrix of a magic tape. I hope you understood magic tape detail.